So whenever we talk about resources, we of course talk about where they come from, what we use them for, what the supply is of them, whether or not we share them with the natural communities, and what is the impact of using them. And finally, of course, we talk about conserving them. This may be conservation because the resource itself is limited, or it may be conservation because using that resource causes a lot of environmental damage, like coal. There's a lot of coal. It doesn't mean we can just use it without regard, but it's not in a short supply. However, we know the mining of it and the burning of it have many environmental problems, and therefore it's better that we not do as much of it, at least, that particular resource, or many of your energy resources, if that's the case. So these are practices, these are things that can be done to reduce the usage of these different ones and avoid the problems that come along with using them. Industry is the greatest consumer of electrical or all energy resources for that matter. Certain processes use a lot of them, certain ones need a lot of heat. For example, metal refinement. When you refine a metal, you oftentimes are reversing the process that made it into what we call an ore, a compound that has the desired metal in it. And therefore, to reverse that process, you have to put energy in it to do it. Sometimes it's in the form of electrical energy or in the form of heat. And of course, a lot of times you have to melt the metal to form it and things like that. You've probably seen the videos of the people working in the steel foundries and stuff where you've got this melted iron and things flowing along, and all that heat energy and everything, of course, is present there. In the past, with these operations, they've just let the furnaces, they've let the heat from the furnace just dissipate out into the environment. Now a more common practice is to, with those furnaces, wrap pipes around them or integrate into the furnace itself. If it's a newer one, these channels where water can be pumped through there and the heat is absorbed by the water, and that heat is enough, of course, to generate steam. And if you generate steam, or if you can boil water, you can do what with that, which we've been talking about? Run a steam engine, steam turbine, and generate electricity. Or you can use that heat directly if you need to heat the building, just for general heating purposes, or you need hot water or something like that for that particular purpose. So using the heat given off or using an energy resource for two different functions is a process known as cogeneration. So that's a good way to conserve energy in an industrial application. Many industrial processes rely on electric motors to do the job. Electric motors are actually quite efficient, but one of the properties of a standard electric motor, old-fashioned electric motor, is that it has only one power level of input. You always put 100% of the power in that motor will run off of, and then if you want slower speeds, you use gears and resistors and stuff that basically waste that extra energy. Now there is a device called a variable speed electric motor that computer controls the power input to the point where you can run if you need to run your motor at half power, at half speed, it'll also only absorb half the energy to do that. So can amount to a big savings in electrical motors, using an electrical motor. Lighting, of course, is needed in places where people are working, obviously, and so replacing your old-fashioned incandescent lights with LED or fluorescent, ideally LED lights are the most efficient, is a good way to conserve electricity in an industry, in a factory, for example. Okay. Of course, a lot of electrical usage is in homes and buildings. So this applies not only at home, but like if you're working in an office or like a school building or something like that. The biggest expense in a structure, most structures that have people in it on a regular basis, is maintaining the climate in there, keeping it warm in the winter and cool in the summer. That, like I said, that's the biggest energy expenditure, and so ways to reduce costs associated with that are primarily increasing your insulation and sealing up leaks. Okay, so doing those two practices alone can significantly reduce energy bills, energy prices. A number of other things like timers on things that don't need to run 24 hours a day. Sensors for lights, if you've ever noticed, like you go into the restroom at a convenience store or something and the light comes on, that's because they're using a sensor rather than using a switch that people tend to leave on. Natural gas. Now, the use of natural gas, and the reason why natural gas is more conservative than electrical just illustrates an overall principle about energy conservation in general, in that you want to minimize your conversions. So hopefully remember before the previous slide we talked about energy efficiency, and the second law of thermodynamics tells us that every time you convert energy from one form to another or you transmit that energy, you lose some of it. Okay, so if you consider using a stove to boil water, okay, if you use an electric stove, you of course are going to be getting your electricity. Your electricity is going to be coming from the power company. We'll use a power company that runs off, or a power plant that runs off of natural gas as an example. They're pretty common. The one that's up here on Lake Monroe is a natural gas power plant. If you're getting that electricity from there, of course, back at the power plant, they're going to have to burn the natural gas, boil water, run a steam turbine, generate electricity through that. Each one of those is an energy conversion, from chemical to thermal, from thermal to mechanical, from mechanical to electrical. Then you've got to transmit that energy through the power lines, bring it into your house, go to your stove, convert it the stove is going to convert it from electrical energy into thermal energy. That's a lot of different conversions along the way. Energy is lost through each one of those processes. On the other hand, if you had a natural gas stove, then you would just simply have the energy conversion right there at the burner of chemical energy to thermal energy by burning that fuel right there. Now you would have to subtract out whatever energy might have been used to transport it there, but if you're like some areas where you have the plumbing in for natural gas lines and things like that already in place, then that energy expenditure is very minimal. So we can see that in general, natural gas appliances and things or combustion type energy usage in-house is much more efficient than using electricity to do so. And although we tend to use heat pumps, which are electrical, they're not an electrical heater like you would have like a little space heater where you have an element. That's a very inefficient way to heat a structure. We tend to use heat pumps in the north, where heat pumps, they won't work lower than a certain temperature because they extract the heat from the outside air. They use a lot of either natural gas furnaces or fuel oil furnaces to heat buildings. You wouldn't try to heat them with a heat pump or straight electricity. That would be very inefficient. So your furnaces, your stoves, dryers, anything that really utilizes heat, using a natural gas or combustion type right there is better than using electricity. More efficient. LED lighting, variable speed motors, again, can be used in the house as well. Your thermostat. So adjusting it lower in the winter, higher in the summer. This illustrates the fact that although we can make a lot of advancements in technology and we can come up with more efficient lighting and motors and capture some heat energy from different processes and seal up the leaks and stuff, part of this is just going to be simply having to change our habits.
Is
Evan was. He's right there.
Bathroom?
Yeah, go check the bathroom. Take a picture of him while he's in there.
Alright, I will.
You can just get the feet right there.
Alright, I got it.
Yeah. Alright. So, this is true of conservation in general. Okay, a lot of conservation can be helped along by technology, by equipment and other kinds of design changes and things like that. But a big part of conservation has to come in the form of personal habits, of changing your thermostat. So it's a little bit warmer in the summer, a little bit cooler in the winter. You're not quite as comfortable. Making sure you close the door after yourself and everything. Same thing with water. Remember we said water, take shorter showers, don't run the water while you brush your teeth, all that kind of stuff. These are all personal activities that people can do to conserve, and that's always going to be part of the equation, okay, whether you like it or not. So your dad or mom is always going to be over your shoulder telling you to do these things. More so because these resources are running out. In transportation, what can we do there to conserve energy? Mass transit's a big one. The more people you can put, or the more goods and everything else you can put on a per engine, basically, the more efficient it is. The United States is terrible when it comes to mass transit. We have some of the least developed mass and public transit systems of any industrialized nation. Florida in particular is really bad about it.
Public transportation?
Yes.
Yeah.
Yeah, and you see, and the thing is, for Florida, really, Florida has not been a very industrialized state for very long. So you do see fairly well-developed mass transit in bigger cities, older big cities like New York, like Chicago. Yeah, and Boston, because those cities actually developed and built out at a time when a lot of people did not have cars. As a matter of fact, they had a time period where the people trying to come into towns, when towns got really crowded, there was a pollution problem with horses, because of course horses poop and the dirt from everything kicking up, and they started telling people they couldn't bring the horses into town anymore. And so from there they started to develop now trains and things were of course around before personal cars were, and the internal combustion engine, and so those were used, and and you got trolley cars that were developed in San Francisco, for example, the subways in New York, transit cars in Chicago's got a very extensive train transit system, and so consequently it's not a new thing in these older cities that were built before a lot of people had their own cars. They don't have parking in a lot of these areas, and a lot of people survive without having cars. So mass transit is, in some places in the United States, it is well developed, but as a country, not so much. And like I said, here in Florida, we don't have very good mass transit systems as well. So I'm a big fan of that. It goes a long way towards a number of problems, not just energy conservation, but safety and allowing people to get to work and things like that. If you are going to drive a car, we have differences, technological differences there as well. But this is also another area in which people will have to start making choices to drive a smaller car, to drive a car that's maybe less comfortable or doesn't have as high performance and those kind of things. Some of the innovations, of course, that we have are things like alternatives to the internal combustion engine that are still in development. And probably one of the best innovations that is taking place there is your hybrid vehicles. Now hybrids are better from a lot of practical perspectives than purely electric cars, just simply because you don't have to plug them all. They do have plug-in hybrids, and I know the batteries will run down if you don't get enough highway driving time where your car can recharge the batteries. But they do have that advantage, and they still have the usage of a internal combustion engine, so you can still put gas in it and things like that. And or if the batteries run down, you can run strictly off the engine. So some of these disadvantages of electric cars are an issue there.
Can you charge electric cars at your house?
Yeah, you charge them at your house.
Overnight?
And that's one of the problems with them, of course, is this long charging time that they require. So there's been a lot of practical problems. Electric cars are not new. They've had them around probably as long as they've had, as long as they've had electric motors. And then I believe electric motors were developed before the internal combustion engine, so I'm not positive there. But they've had electric cars for some time, but they really have not met people's needs as well as your typical internal combustion car. You guys have a question over there, something?
Yeah.
Internal combustion. I'll write it out bigger for you guys. Sure. Which is your standard gasoline or diesel powered vehicle, runs off an internal combustion engine. And it's an ideal technology for what we want to do for personalized individual vehicles. It's a compact, not only compact engine itself for the power you get out of it, the fuel supply is compact. Diesel and gasoline are good compact fuel supplies. You can go hundreds of miles on a tank, etc. But of course the problem is that petroleum is running out. And of course, they produce air pollution. Yeah.
What's the main difference between a hybrid and an electric?
So now, with the difference between a hybrid and electric, I'm glad you asked that. With a hybrid, you still have an internal combustion in there. That's your part time.
So it still takes gas?
It still takes gasoline. This part operates at what we call cruising speeds, after you get up to above 30 miles per hour. One of the things, properties of electric motor that is an advantage is it can accelerate very quickly. So they take advantage of that, of having the vehicle accelerate using the electric motor, and then cruise using your internal combustion engine. And as a matter of fact, it works better. The fastest production car in the world right now, it's a Porsche, I believe, is a hybrid car. because you just get a lot greater acceleration from electric motor than you do. And most of your gas when you're driving, and most of your gas comes when you accelerate. Use most of it then, and therefore that helps to solve that problem. Okay, but you still have some reliance on gasoline, so it's not perfect in that respect, or diesel. Then that also we have to consider purely electric vehicles, and I want you to think about for a minute if, that's not it by the way, if an electric car is always better for the environment. Is an electric car always better for the environment? Who can tell me why maybe not? What situations? Andrew?
You plug your car into your, like the grid or whatever that you're on.
Yeah. Come on.
See, and please don't kick me out.
Oh, you gotta go, Kenzie.
The power could be coming from a power plant that's powered by coal or...
Very good. That's exactly the point. If your electric car, if you're plugging it in, an electrical power source is a coal plant or even a diesel fuel plant. There's not many of those left, by the way. But a power source, electrical power source that is not very good for the environment, then you're not doing the environment any favor by running electric cars. As a matter of fact, it is less efficient because they've got to burn that fuel source at the power plant. It's got to be transmitted to where that car is getting charged up. And overall, you're probably putting more carbon dioxide in the atmosphere, more pollutants. Gasoline is a relatively clean burning fuel. Diesel not so much, but gasoline is a relatively clean burning fuel. So it doesn't help in that respect. Yeah, we're good.
I was just gonna say, in California, you know how they have like a carpool lane because they want to encourage people
They have it here
to
too.
carpool. Oh, well, like on all the major highways.
Yeah.
You can also add an energy. You can, if you have a hybrid or electric, you can drive.
You can use your hybrid or electric in a high occupancy vehicle lane. Yeah, that's
why I'm getting
interesting.
Because I'm moving it.
Okay. Well, how are you going to get there?
Drive.
Yeah, see, there you go. You're just using up all that positive impact by driving over there.
Yep.
But yeah, carpooling be encouraged. As McKenna mentioned, you have these carpool lanes, HOV lanes, high occupancy vehicle lanes, which means you have to have at least 2 people in your car or yourself and a mannequin. There are ways that we can encourage those different types of things, usually through types of government regulation. However, probably the best idea if they can get this technology where it's affordable is the use of hydrogen fuel cells. Because we've already discussed the fact that hydrogen gas can be generated anywhere you generate electricity. And then hydrogen fuel cells themselves are about 60% efficient. That's good. They produce water vapor as a byproduct. That's not a pollutant. And so there are many advantages overall to hydrogen fuel cell technology. The only problem now is it needs palladium to run, and palladium is a very expensive metal at this point, so that's made the cost at this point somewhat prohibitive. A lot of places have alternative energy buses running either off of biodiesel or off of hydrogen fuel cells. So we may see more of that in the future. It's easier with big buses and things like that to incorporate some of these than it would be to put them in a bunch of cars and use them. But that's a wave that we're finding take place. Urban and suburban sprawl. This is another issue. Over the past 60-ish years, since post-World War II, there has been a migration of people out of cities to living in the suburbs. Part of this actually was fueled, no pun intended, by cheaper oil and gas prices when they discovered oil in the Middle East. That made gasoline much cheaper and therefore easier to drive to work and everything. That obviously is going to add to the burden and everything of fuel, having an hour more commute for many people to get to and from work. And we can reduce that, or that can be controlled somewhat through proper city planning. And once again, like I said, with older cities that were built primarily before a lot of people had cars, they did this. They would space things out so you had people living in residential areas. They had, your offices and other places you would work would be close by. You could walk there or take a cab. You'd have, corner market like grocery stores. Didn't have big box stores for the most part. that people would go to, and they'd be able, you could live, and you can still, you can live in New York and many other big cities without a car quite easily. But they have all these other things in place, not only more public transit, but they have the city itself is planned out in such a way that the amount of travel time is minimized. So that's something that we can learn from the past in that particular circumstance. And then finally, minimum mileage requirements. And this is a government regulation that is in place now and requires automobile manufacturers to, of the automobiles that they offer, their fleet is what they call it, they have to have a certain minimum average mileage, miles per gallon. Okay. So you may say, well, yeah, Ford's producing a SUV that gets like 12 miles to the gallon. How can that work with if the 25? If it's, I think it's like 26 miles per gallon now is the average. They have to, if they do that, they have to also manufacture and offer something that gets 40 miles to the gallon to balance it out. This still does not influence consumer choices, what people buy. That has been shown that the only thing that really affects that is gasoline prices. As a matter of fact, I would imagine this year, and as if gasoline prices stay down like they have been, that you're going to see a definite upswing in the number of low mileage vehicles that are purchased. So that's just a consumer choices. Like I said, your choices and habits are also going to be a big part in this whole thing overall. Any questions on energy conservation? Okay.